thank you for participating in the Well-Nourished, Brighter Futures, which is a Let's Eat Healthy initiative and webinar series. My name is Ashley Rosales, and I'm a registered dietitian nutritionist and the program director of nutrition science at the Dairy Council of California. As a nutrition education organization, Dairy Council of California has empowered stakeholders, including educators, health professionals, and community leaders to elevate the health of children and families through the pursuit of lifelong healthy eating habits for over 100 years. The purpose of the Well-Nourished, Brighter Futures initiative is to invite experts from across disciplines and sectors to come together, like we're doing here today, to find opportunities for collaborative action that lead to a future where all children are supported to grow healthfully and to reach their full potential. With the number of priorities critical to overall child health growing, their nutritional needs can be easily overlooked, which poses a risk for inadequate consumption of nutrient-dense foods during childhood and beyond. So working together is essential to help ensure that all children and their families have access to nutritious foods and environments that support lifelong healthy eating habits where they live, learn, work, and play. So with your participation in the Well-Nourished, Brighter Futures initiative, we hope to establish key principles that can address the unique nutritional needs of children across critical life stages. And we invite the sharing of promising opportunities to support children with proper growth and development while preventing obesity and other chronic diseases and building a strong foundation for learning and lifelong success. So thank you for your time, your expertise, and collaboration to help find solutions to ensure all children, but especially those in vulnerable households, are well-nourished and supported for a brighter future. I also want to thank the Glenn Price Group for their support and collaboration in this initiative. I'm pleased to introduce today Christopher Scassese, Senior Associate with the Glenn Price Group. Christopher.
Thank you, Ashley. I'm not sure that everybody knows who the Glenn Price Group is, so just briefly, I would say that the Glenn Price Group is a results-oriented consulting firm providing services and support for collaborative efforts, planning, facilitation, research, policy analysis, and fund development. We work with public agencies, including educational institutions, nonprofits, and foundations. We work at the local, state, and national levels. I think in the context of our discussion today, it's worth sharing a little bit from our mission statement. Our mission statement has one piece that talks about the importance to us of contributing to a just and equitable world and improved outcomes for all, beginning at birth. So I thought I would add that because I think we are certainly aligned with the excitement of this promising initiative. So I could say a little bit more, Ashley, about why we're excited about supporting this initiative, if that's appropriate.
Yes, go ahead.
Well, one thing we've learned as a consulting firm over the years is the importance of bringing together different stakeholders in identifying shared goals, common ground, even shared values. That when we bring together a collaborative of folks that may be working in silos, we can have a greater impact in the work that's being carried out. Not to dismiss the work that's being carried out by individual organizations and groups, but there's an opportunity to leverage that work in a more impactful way in coming together with others. So we're very excited to join this initiative because at the heart of this initiative, besides well-nourished, brighter futures, is actually to bring people together towards shared goals and see how strategically there could be more impact in supporting the important work that has to be carried out in the state of California for child nutrition. So thanks for the opportunity, Ashley, for letting us join your effort.
Thank you. That's a great point. The goal here is for collaboration and to take all of these perspectives and promising practices into how we can build these for the future of California's children and beyond. So thank you, Christopher and Glenn Price Group. So today we have the opportunity to hear from Dr. Jennifer Smilowitz, Dr. Smilowitz is a faculty affiliate in the Department of Food Science and Technology and Associate Director of the Human Studies Research Program for the Foods for Health Institute at University of California, Davis. She holds a doctoral degree in nutritional biology with an emphasis in endocrinology and completed her postdoctoral fellowship in food science from the University of California, Davis. Dr. Smilowitz also holds the position of Director of Scientific and Strategic Development for the nonprofit organization, the International Milk Genomics Consortium. She has a well-established career in lactation and milk science, particularly human milk and clinical nutrition. Her approach to solving complex problems involving health and disease relies on implementing randomized controlled trials, cross-disciplinary and multi-collaborative methods. She has published more than 60 scientific articles in peer-reviewed journals on lactation, milk and dairy science, and the gut microbiome across all life stages. She and her team recently received the prestigious UC Davis 2020 Chancellor's Innovation Award for advancing infant health through microbiome restoration. That's very exciting. As a certified lactation educator, Dr. Smilowitz supports breastfeeding and researches dietary solutions that support the health of the mother-infant dyad. She regularly gives lectures on the benefits of breastfeeding and its impact on the gut microbiome to healthcare practitioners across Northern California hospitals, clinics, and also with the WIC staff and program, Women, Infants, Children. Her research program that she has built over the past 15 years has led her to the conclusion that improving the human condition starts with the health of babies. The first 1,000 days, from pregnancy through a child's second birthday, is a critical period in life when diet and lifestyle largely influence long-lasting health. Diet and lifestyle during these early stages of life have long-term consequences to human health and the breadth of individual potential. Dr. Smilowitz's current research program at the University of California, Davis is widely translational, and she is currently conducting several ongoing intervention trials involving diet that supports the growth and beneficial gut microbes and the healthy immune system in infants, children, and adults. So by the end of this discussion, we hope that you have been provided with some thought-provoking information and perspectives on how we can all come together to address and support the unique nutritional needs of children, especially starting in the first 1,000 days of life. Thank you for being with us today, Dr. Smilowitz.
Oh, Ashley, thank you for the introduction, and thank you for having me be a part of this collaborative effort. I am so excited to be here, and I want to thank the Dairy Council of California for including me in the conversation. So let's get started. So today's talk is entitled Healthy Eating Patterns During Critical Life Stages That Are Essential for Optimal Health and Development. And this topic is extremely dear to me because this is what I research, and I am confident and I believe that the first 1,000 days are so critical to intervene, that this is a period that really sets a person on the right trajectory toward lifelong health. And so this is what I research, and I focus a lot, mostly on lactation, breast milk. And the reason why I focus on lactation is because lactation has evolved over millennia, many millennia, to provide growth, development, and support and protection for the infant. And so when we look at breast milk and we take it apart, we can understand that it's so complex that it really targets so many different biological systems to support health, that we can really learn from it and apply it to other populations, not just babies. So I hope that I can shed some light onto what we are researching and why we can apply it for the first 1,000 days. Again, I'm happy to collaborate in any way. If you want to get in touch with me, you have questions, or you want to find out more about me, there's a lot of information you can access here through my email, Twitter, Facebook, and website. So we'll talk today about why we need to focus on the first 1,000 days, why that's really instrumental, and how we should think about food, how we should think about providing nutrients to the mother, infant, and child. Should we think about food as a food pattern, or should we think of single nutrients? What's the difference? And of course, there's lessons to be learned from lactation. So we're going to talk a lot about lactation and how lactation delivers health at various targets. So we're going to talk about targets of health to focus on during the first 1,000 days. So when you're thinking of food, you should think about, you know, the body is very complex, biology is complex, food is complex. We need to target multiple systems at the same time, and food can do that. Food patterns can do that. So what are the targets of health we should focus on, and what are examples of food patterns that target health? So pregnancy, infancy, early childhood, the first 1,000 days is this continuum, starting with pregnancy to the child's second birthday. And it's a critical period in life where the mother is going through a very complex period in her life where her metabolism is taxed. She is creating life. She is creating a human being inside her uterus. And so her tissues are going to be dissolved to make this person, and she's shuttling nutrients from her diet to make this person. So she's got metabolic demands that require adequate nutrition so she can sustain herself, her health, and provide the best optimal nutrition for her growing fetus. She's also immunologically compromised, and which is a good idea, right? Because you don't want the immune system to attack the baby. So she's susceptible to infection. So we need to understand what is going on with mom and what are her needs so that she can support a growing fetus, and so that fetus obtains growth and maturation and development in an ideal way. And then we look into, so we transfer that health into the infant, and we know that mom is making milk. If she decides to breastfeed, she is going to make food for her infant, and that is going to also require that she consumes adequate nutrition, because that milk requires food, nutrients, and it's either going to come from her tissues and or her diet. So she's making milk, we need to support her. We need to think about dietary patterns that are going to support her needs, and while the child is consuming breast milk, which is the ideal food for an infant, as the infant is developing his immune system, her microbiome, her brain, and her growth. She has high demands as well. And then we transfer this over to the child stage. Now, children are rapidly growing, their brains are rapidly developing. By 3 years of age, a child's brain reaches about 80% of an adult size. By 5 years of age, their brains are about the size of an adult, by 90% of an adult size. So we need to support that development. They have a huge need, and so food is going to provide that to them. So we need to understand what nutrients should we focus on, but should we focus on nutrients or should we focus on food patterns? And that's what I want to talk about. I want to talk about the difference between feeding people in terms of thinking about food and food patterns versus single nutrients, and what is the difference. So nutrition and food science has been around for centuries, but modern nutrition science is a really young field. We're talking about the early 20th century. Single nutrients were born. So vitamins and minerals were discovered. They were isolated and synthesized. And with World War I and with the Great Depression, there were food shortages. And so people were suffering from nutrient deficiency diseases. And those nutrient deficiency diseases could be cured with the single nutrients that they were lacking. And so this is a reductionist approach. If you're lacking one nutrient, just feed it to that person, and then you no longer have a nutrient deficiency. And so the recommended dietary allowance was established in around the 40s to prevent deficiency diseases from occurring during World War II. And so in the 60s and 70s, the idea of delivering these nutrients with using food as a delivery system became very popular. And so we see fortification of foods with the single nutrients to prevent these nutrient deficiencies. But chronic diseases were on the rise. heart disease was a big issue. And there were studies that showed different single nutrients, fat or sugar, had different impacts on heart disease. Well, it turns out fat won, and the guidelines were set that recommended that people eat a low-fat diet. And so because fat was reduced in the diet, another nutrient had to increase, which is sugar. So fat was lowered in the diet and sugar was increased. And now the dietary guidelines focus not only on single nutrients to prevent nutrient deficiencies, but also single nutrients to reduce chronic diseases. Well, it turns out around 2000, 2010, that many clinical trials were showing that chronic diseases are actually really complex and you can't prevent them with single nutrients. In fact, it turns out that food patterns were the most important in terms of addressing complex diseases like chronic disease, heart disease, type 2 diabetes, cancer. Single nutrients can't solve those problems, they're too complex. Now, nutrition research is moving in a different direction. The future of nutrition research focuses on new dietary complexities. So we're talking about things in food that involve interactions within food that interact with multiple biological systems in our bodies. For example, we know now we have to feed our microbiome, the bacteria that live in our gut. We're not just eating for one, we're eating for two, and the foods we eat affect our microbiome. When we have a dominance of beneficial microorganisms in our gut, then we have effects on our brain that are improve cognition, mood, satiety. We have less inflammation in our body. We have less pain. We're more regulated in terms of our metabolism. We also have to think of food as quality, not just quantity. So you have to think not just counting calories to lose weight, but the quality of the food that you're delivering to the person. We have to think about nutrient-dense foods, not just calories. And we need long-term studies on understanding the effects, the long-term effects of processing and additives. We don't know very much about how these different processes are going to affect our long-term health. And this is the future of nutrition science. Now, what are food patterns, right? So we know what single nutrients are. So iodine, you add iodine to salt. You can eat some iodine in your salt, you're fine. Iron fortified cereals. You can feed your toddler iron fortified cereal and you know that your child is going to get iron. But food patterns are complex. We define the complexity by the components, the structure and the matrix of the food and how they work together to synergize and target biological functions. So what's an example of a composition? Well, first we're thinking of the components in the food. So we're protein, and in this example, we see yogurt with fruit, right? So you have protein, polyphenols, polysaccharides, which is basically carbohydrate, and lipid or fat. And those are the actual components. That's, if you want to break up the food, those are the chemical composition or chemical components. The next thing to think about is how those components or the chemicals themselves, the molecules, are bound to one another, how they are structured. So if you have bricks, if you want to build a house, if you have bricks, well, how are you going to cement the bricks and what kind of shape and form are you going to create when you're building this structure? And that's the structure itself. And then we're talking about matrix, which is the composite, the overall interaction among all the components and their structures together. So matrix is essentially the house, right? So the composition, you think of bricks, the structure is how you're going to line them up and cement them. And then the matrix is the entire big picture house, full, the final product. And then other things to think about when we think of food patterns are other components that are non-nutritive. So we're not talking about a vitamin, a mineral, or a macronutrient like fat, protein, or carbohydrates. We're thinking of other components in food that don't deliver nutrition, but that promote other functions like growth, protection, and development. So for example, a polyphenol, which is a molecule that is a color compound in a fruit or a vegetable, does not deliver any kind of nutrition, but other antioxidant properties, which is beneficial still. Fiber, same thing. They feed our fiber. Fiber doesn't necessarily provide nutrition to us, but it provides nutrition to our microbiome, and we want a healthy microbiome. So these are things to think about. So complexity, food patterns, the matrix, and non-nutritive components. And so we see that food synergy, so that interaction of all the components in the structure in the matrix that have beneficial effects on the body, not just one problem, but overall. We learn a lot from lactation. And the reason why is we know that milk, breast milk, is the gold standard food, is the biological food made for infants. And infants benefit, and so do their mothers, from breastfeeding. And in fact, the World Health Organization recommends exclusive breastfeeding for the first 6 months of life, and then continue with breastfeeding with complementary feedings up to 2 years and beyond. We know that universally, breastfeeding prevents 823,000 deaths per year in children who are 5 years and younger. We know that it protects against various infections like respiratory tract infection, gastrointestinal infections, ear infections. Universally increases IQ, protects infants from sudden infant death syndrome, which is a leading cause of mortality in infants in the US. We know that longer duration of breastfeeding is associated with lower risk for overweight, obesity, type 2 diabetes later in life. And even for mom, it protects her against various cancers, type 2 diabetes, and heart disease. There's one example I want to talk about, and that's the matrix here with breast milk. So you probably are familiar because of the last slide. 87% of milk is made from water, and we have the macronutrients and the micronutrients. Of the macronutrients here, lactose is the highest amount, provides energy to the baby. Lipids supports brain development, and protein growth. And then you have this other component, human milk oligosaccharides, HMOs, human milk oligosaccharides. So human milk oligosaccharides are basically complex sugars, and they look like this. Each shape is a single monosaccharide, is a single sugar, and each one is bound by this bond, basically a glycosidic bond. And in order for the baby to utilize the sugar, she would need to possess the enzymes to cleave each bond and absorb each of these symbols, right? Each sugar. But guess what? Humans don't have the enzymes to break this down. And they're complex in structure. This is like a fiber, for in human milk, essentially. And there are 200 different structures in human milk. So they're really complex and they're very diverse, and they're not digested by baby, but they are food for microbes. So mom is spending a lot of energy to make all this nutrition for her baby and food for microbes. So which microbes, and why is this important? Well, it turns out there's just a specific subset of microbes in the gut of breastfed babies that can consume these human milk oligosaccharides, these HMOs. And HMOs are now called a prebiotic, a food for bacteria. But this subset of bacteria, we call them a milk-oriented microbiome, or MOM. They belong to the genus Bifidobacterium or B. infantis. It's this beneficial microorganisms, but breastfed babies have it. Formula-fed babies don't have it because formula does not deliver human milk oligosaccharides. So it's a prebiotic, a food for good bacteria. And we wrote about this. We had a cover article in The Scientist in June, and we wrote all about this. And if you're interested to know more, I highly recommend reviewing this article. It's quite fun to write. The other thing that human milk oligosaccharides do is they bind to pathogens. Pathogens are the bad bacteria. That's the bad guys. And they bind to them and prevent pathogens from binding to our intestinal cells, which is how they infect our cells. So they act as this pathogen decoy. They bind to them and they force them to be excreted. So human milk oligosaccharides in breast milk are not digested by baby. Moms are making them. They are the third most abundant component in human milk, higher than protein. Babies don't digest them. They're fed to specific microorganisms that are only found in breastfed babies. So it's a food for that bacteria. That bacteria, when it grows, when it dominates, it protects the gut. And that's critical. That's one of the ways that breast milk is so protective, by feeding good bacteria during early life. So when we're thinking about the first 1,000 days, the 3 targets I want to focus on today, and there are many targets, right? The body is complicated, but I only have so many minutes to speak today. So I want to focus on the metabolism, metabolic and growth, immunological and neurological demands during the first 1,000 days. So we're going to talk about these 3 targets. The focus right now is on infancy and childhood. So the 3 targets apply here. On the left-hand panel, you see that the development of the microbiota, which is the bacteria in the gut, and immune system develop rapidly in childhood, in infancy and childhood. And the key here I want you to think about is that 80% of the immune system lives in the gut. 80% of the immune system lives in the gut, and the microbiome communicates and educates the immune system. And so when you have good bacteria, you have good bacteria educating your immune system early in life. If you have more bad bacteria, the pathogens, you have bad educators educating the immune system. And you can see that these two coincide with one another in terms of maturation. The next thing to focus on is brain development. And you can see early on that in infancy, brain is developing rapidly, and it becomes, basically you've got synaptogenesis, myelination, neurogenesis, all these different processes that are formed and developing in the brain, and it's rapid, especially by 3 years of age. Like I said earlier, infants, their brains become 80% of the size of an adult, and by 5 years of age, their brains are about 90% of the size of an adult. So there's rapid development, and from infancy all the way to childhood, and this is an opportunity when we need to make sure that we are feeding the brain so it develops and reaches its potential. And of course, children are growing rapidly, and so we need to make sure that they're growing and not stunted, because when children are stunted, they have poor cognitive performance, their brains also don't develop, and they have other problems like immune system problems. So we need to always address these 3 targets. I'm happy to add more because the body is very complicated, but for today I want to focus on these 3 targets. So here are the 3 targets. All 3 are influenced by diet. So diet influences the development of the microbiome and immune system. Diet influences growth and metabolism, and diet is important for developing the brain. And they themselves also interact with each other, right? So the microbiome and immune system communicates with the brain. And microbiome and immune system affects growth and metabolism. And growth and metabolism affects brain development. So it's not just diet alone, it's how these interact with one another. So it's complex. So I'm going to talk about the microbiome. What is it? What does it do? So when you eat for 2. When you're pregnant, you eat for 3. So when you eat, and you eat non-digestible carbohydrates, so we're talking about fruits and vegetables, legumes and nuts, and even fermented foods, we are influencing our microbiome. The majority of the microbes that live on you and in you are found in the colon, the large intestine. And when we eat these foods, we don't digest them. They actually make it to the colon, and they feed our beneficial microbes. And when the microbes eat these non-digestible carbohydrates, we know them as fiber, then they produce molecules. Some molecules actually feed back to our brain and help us improve our cognition, our mood, and satiety. So there is definitely a connection between the gut microbiome and the brain. When beneficial microbes consume fiber in our diet, they produce short chain fatty acids, so SCFA. Short chain fatty acids are really important because they change the acidity of the colon, and they lower it. And pathogens, those bad guys, they don't like that acidity, so it keeps them at bay. That's one thing short chain fatty acids do. Another thing they do is they fortify the gut. So if you've ever heard of a leaky gut, well, this is the opposite. You're fortifying the gut. The third thing that short chain fatty acids do is they enhance the absorption of vitamins that are in our diet. They make them more available or bioavailable. So there's so many things that are going on when we're feeding beneficial microbes with our diet. We're not just feeding for ourselves. We have to think about our microbiome. Our microbiome also detoxifies carcinogens that we consume. Our microbiome also helps develop the immune system. If there are too many pathogens around, they will help stimulate the immune system to release antibodies that are released into the lumen of the gut, the inside of the gut, to basically neutralize or bind and excrete the pathogens. They also produce vitamins for us, vitamin K and other B vitamins. And they also produce little antibiotics, these little peptides that attack pathogens. So our good microbes help us in so many ways. We don't even know that what they're doing. So we need to feed them. So, but what happens when you have, an imbalance? So there's also a mixture. So when I'm talking about these microorganisms that do all these wonderful things for us, we call them commensals and symbiotes. Those are the good guys. We want to feed those guys. But there's a time when we might have more pathogens. Those are the bad guys. And when you have more pathogens in the gut, then you see a disrupted or dysregulated gut microbiome and increased risk for chronic diseases ranging from type 1 diabetes, asthma, allergy, inflammatory bowel disease. We'll say, basically the whole body goes over, it's awry. And so one major factor that supports a beneficial microbiome, especially early in life, is diet, which is breast milk. Breast milk feeds the good guys. And we want to make sure that infants are dominated with the good guys so that the bad guys stay in the sort of lurking in the shadows, but aren't really taking over, don't have much of an influence on the immune system that is developing. So, but unfortunately in the US, breastfeeding rates are really low. So the exclusive breastfeeding rate at 3 months is basically 47% of infants in the US are exclusively breastfed at 3 months, and only 25% of infants in the US are exclusively breastfed at 6 months. And remember, the recommendation is exclusive breastfeeding up to until 6 months of age. So we're not really meeting the World Health Organization's recommendation. Unfortunately, more mothers are feeding their babies solid foods before 4 months of age, 40%. And we know that gut microbiome dysfunction, so having more bad guys than good guys, has become more common in resource-rich countries within the past year, within the past 100 years. And this figure shows you the percent of bifidobacteria. So this is the good guys that represent the microbiome in breastfed infants. And you can see that about in American babies who are basically what we're seeing is 35% of their microbiome is composed of the good guys, bifidobacterium, compared to babies from Bangladesh, Gambia, Malawi, where exclusive breastfeeding is common. And basically the good guys, bifidobacterium, represents up to 80% of their microbiome. So why is this important? Because we know that there's a rise in metabolic and immune-related diseases in the US and developed countries where breastfeeding rates are much lower. We're talking about increased asthma, allergy, type 1 diabetes, and obesity. So these are diseases that are implicated in a dysregulated microbiome in infancy. So more bad guys than good guys. So current US children's eating patterns and health outcomes are really subpar. And unfortunately, only 40% of infants and toddlers regularly eat vegetables. And so we talked about how important it is to support a healthy gut microbiome. Vegetables are really important in this period of life. 40% is just too low. And over 40% of infants and over 70% of toddlers eat some kind of sweet, a dessert or a sugar-sweetened beverage at least once a day. And 10% of children under the age of 2 are overweight or obese. Now we know that from many studies, there's no doubt that excess weight gain in children and unhealthy eating patterns are associated with poor academic performance. So we need to change this. This is one of the first things that we need to focus on is what children are eating early in life, because when you have poor academic performance, then you have poor outcomes in life in general for their future. So let's move on to okay. And so you can see this here, that healthy eating patterns are associated with cognitive performance and increased academic performance. So Participating in a school breakfast program, for example, is associated with improved cognitive performance and increased academic grades and standardized test scores and reduced absenteeism. But skipping a breakfast decreases cognitive performance. When children have a lack of adequate consumption of nutrient-dense foods, so vegetables and fruits and dairy, and when they have deficits in specific nutrients that are important for brain development, and insufficient food intake, these all lower grades, they lower cognitive performance, and they result in repeating grades and inability to focus. So it's really important that we get it right early. So nutrition is the foundation for the developing brain and for learning. We know that adequate nutrition fuels the growth and development of the brain early in life. And it lays the foundation for cognitive abilities, motor skills, socio-emotional development, which in turn is really critical for influencing success not only in school, but economic opportunities later in life. And the next target I want to focus on is growth and development. Now, like we mentioned earlier, when a mom is pregnant, she is metabolically taxed. She is creating a human being. She's making bones and skeleton. She is making muscle and organ systems, brain. All of these things also have to function. They're not just sitting there. And so she's being taxed. She needs proper or adequate nutrition. At the same time, there are other kinds of metabolic demands. We see that women in the US, 50% of women in the US gain excess weight during pregnancy. And this is a risk factor for gestational diabetes. So women who gain excess weight in pregnancy also develop diabetes during pregnancy, which is called gestational diabetes. They are at higher risk. In fact, up to 14% of pregnancies are diagnosed with gestational diabetes. And unfortunately, we see higher rates of gestational diabetes in women from Hispanic and other races and ethnicities, and also higher rates in non-Hispanic Black women than in non-Hispanic white women. And so many of these racial and ethnic disparities are a result of not receiving adequate healthcare and education with their healthcare team, and also because of food insecurity. I mean, the fact is healthy foods are expensive, and unfortunately, a lot of the reason why people develop gestational diabetes has a lot to do with not having access to healthy foods. And we know that women who develop gestational diabetes have a much greater risk at developing type 2 diabetes within 10 years after pregnancy. So this is a big problem that we can prevent if we get it right in the beginning, early on. Now, when a mom is pregnant, when she's pregnant and she develops gestational diabetes, there's risk to the child. The child has reduced cognitive function, has a higher risk for becoming overweight, obese, and develop type 2 diabetes later in life. So the American Academy of Pediatrics came out with these recommendations in 2018 to address the first 1,000 days to support growth in neurodevelopment, because obviously this is the time to do it. It's a critical window of development. And so there are many very important nutrients that I would love to talk about, and I'd love to talk about all of them, but today I want to talk about 4 that are highlighted in red, because I want to give you examples of how different food patterns can deliver each nutrient differently. So let's talk about composition first. So remember, we talked about food patterns deliver composition, structure, and matrix. Now, one component in the diet is that I'm really interested in is choline. Now, choline we make in small amounts, but not adequately. We actually have to acquire it in our diet, especially women who are pregnant, because there's a high demand for choline. Choline is a component on the membranes of our cells. They're really important in regulating the metabolism of fat in our bodies. They're precursors for basically like a hormone involved in neurotransmission or communication between the nerves and the brain, and methylation, which turns on and off genes, which you want. Basically, you want the genes to turn on when they're supposed to and turn off when they're when they're supposed to. So choline is important for developing the placenta, for developing the brain, and for turning on and off genes when they're supposed to be turned off and turned on. And that's really critical during pregnancy, especially. And as you can see from the adequate intake recommendation, there's a higher need during pregnancy and lactation. Now, there's no recommended dietary allowance established for choline, but there's an adequate intake. So there's a suggestion, but really, and that's because there's just not enough evidence to create a recommended dietary allowance. But choline is complicated and needs to be further studied to really show that this need in pregnancy is essential, right? And when we talk about the foods that contain choline, it turns out the best sources are actually animal sources. So a mother could eat 100 grams of beef liver and she can get all of her choline requirements in, but unfortunately beef liver isn't a very popular food, but you can see that basically it's the animal sources that contain, that are rich in choline. Another food or another nutrient I'd like to talk about is iron, and I want to focus on the food synergy where we're looking at structure, and structure here plays a really big, important role in iron. So there are two forms of iron that we get in our diet. Heme iron, which is basically heme is a protein found in animal sources, and it's bound to iron. And then there's non-heme iron, so it's just iron that's just free, and we find non-heme iron in plants and in fortified foods. And so here's an example. You can see heme sources and non-heme sources in this picture. Now, heme iron is better absorbed than non-heme iron because this protein is basically shuttling the iron into the cell. So it's protecting the iron. Non-heme iron is susceptible to other components in our diet that are found in plants and grains. And so these include phytate, oxalic acid, and polyphenols. And so if you look here, you can see a list of phytates are found in grains and nuts, and they basically prevent the absorption of not just iron, but other minerals like calcium, zinc, and magnesium. And of course, we know that spinach is loaded in iron, right? This non-heme iron, but it also has oxalates or oxalic acid, which prevents the iron from being well absorbed. Tannins or polyphenols, they're found in wine and tea and chocolate. We don't have to worry so much about the baby with that one. But, you know, if we're thinking about pregnant women, not drinking wine, eating chocolate or tea, but we have to think about there are other components in food that can interfere with the absorption or the availability of minerals. And one is that, you know, we have to focus on food structure, essentially. Now, unabsorbed iron, what happens is when it gets to the colon and you get a lot of gastrointestinal distress, and we see that a lot with children, toddlers, who are consuming iron-fortified cereals, for example. They get constipated, they are bloated, they have tummy aches. And we also see that there's an increased growth of pathogenic bacteria when iron is not absorbed, and that's because pathogenic bacteria also need iron, and they're there to receive it. Also, high-dose non-heme iron supplements can interfere with zinc absorption. So structure matters. Now I want to talk about the matrix. Okay, so breast milk contains more than 200 different proteins. And those proteins are grouped into either casein and whey, like curds and whey, casein and whey. Now, these proteins are high quality. They're complete proteins. What does that mean? So they have all of the amino acids necessary for efficient growth and in large amounts, enough for sufficient growth. Now, if we look at whey, the whey fraction, we call that the protective fraction because this is the fraction that has all of those antibodies and other antiviral, antibacterial proteins that are really important, including lactoferrin, which is a protein that facilitates iron absorption. So not only are we delivering a really high quality complete protein with breast milk, but we're also helping iron become absorbed. So that's multifunctional. Now, we call whey a fast protein because it's easily and quickly digested and absorbed, and it's been shown to improve growth in infants. It's very important for growth. It has various different kinds of amino acids called branch chain amino acids that have an effect on development of growth, and also important for satiety. Lots of things going on with whey. Brilliant protein. Okay, next, casein. So casein we call a slow protein, and you can see casein on the left-hand side. It's a complex protein. It's made up of these micelles that also are bound to calcium and phosphorus. So we call this a slow protein because it takes a while to digest and absorb the amino acids. It takes baby, more time to receive the amino acids in her bloodstream than whey, which is great because then she has sustained release of amino acids essentially. And 20% of the calcium found in milk is bound to casein, which facilitates calcium absorption, and phosphorus both are needed for bone growth and development. And guess what? No inhibitors are found in breast milk. Now, the last thing that's fascinating about proteins in milk, in human milk especially, is that the whey composition and casein composition change over time. So in early lactation, or colostrum, around the time of when the baby's born, in the first week or two of age, we see that most of the protein is found as whey. 90% is whey, 10% is casein, which is really critical because when babies are born, they're completely immunologically immature. So they need this protective protein. They also don't have the digestive capacity to digest that much casein. But as the baby gets older and her immune system matures and her digestive capacity improves and is maturing as well, then you can see there's a 1-to-1 ratio between whey and casein. So milk is brilliant because it's responding to the needs of the infant and the demands. Now, infant formula and cow milk have a different composition of casein and whey. Bovine milk or cow milk contains 80% casein, 20% whey. And so it makes sense that this is why we give cow milk to toddlers, not infants. Breast milk is the best food for infants. And then finally, the other thing I want to talk about in terms of food patterns is these non-nutritive components. And what's really dear to my heart are these fermented foods. So the more fermented foods we eat, the more complex carbohydrates we eat that are non-digestible, we're feeding our healthy microorganisms in our gut. And so one example of fermented foods include plant foods like sauerkraut, kimchi, pickled vegetables, and then of course fermented dairy. And I'm a big fan of fermented dairy because not only are you consuming those microbial cultures, but you're also consuming a high efficient protein. You're receiving calcium and vitamin D in this complex matrix. And so I highly recommend focusing on fermented dairy in pregnancy and especially in toddlers. Now, breast milk is obviously the best food for infants because it delivers the HMOs, the human milk oligosaccharides, those prebiotics that feed the beneficial microorganisms in the gut, and all those immune components that are protective. And then, of course, we should all be eating plant foods with fiber and also color compounds. Don't just think of fiber alone, but these polyphenols in plant foods are really important for the microbiome also, not just the fiber. And so I'd like to conclude that I hope that I was able to convince you that the first 1,000 days is a critical period in life when metabolic demands of the mother-infant dyad are high and the infant child's immune system, the gut microbiome and brain are rapidly developing. That we know that nutrition research of the future is emphasizing food patterns. That's where we're going. We're addressing complex biological processes. We're not using single nutrients to address single nutrient diseases. We can't do that anymore. We're done with that. We solved those problems. We need to focus on food patterns that target multiple complex biological processes that are critical for lifelong health, not just one or two, not just heart disease, but the whole body. We need to focus on lactation and learn from lactation as a food pattern that delivers that food synergy that supports growth and protection and development and can be applied not just to babies, but to all populations, from athletes to the elderly. And the food patterns need to address multiple complex biological systems for lifelong health and success of the mother-infant child dyad. And I thank you for your time. I hope that you found this webinar interesting.
That was so fascinating, Jennifer. Thank you for covering very complex information in a brief, considering what you were able to, bring forward to our attention period of time. So your passion for the first 1,000 days definitely comes through, and so much information for us to continue to dig into and assimilate as we look for how to implement several of the ideas that you bring up that will improve the health of not just the pregnant mother, but also that infant, and then growing into that child as they grow as well. So we'd love to be able to pose a few questions in summary of this great information. And knowing that you have such an extensive background and research area in this area, can you say what you think maybe one or two important achievements or successes would be that you could summarize?
Oh, absolutely. So I think that, so the huge success is that we already know that single nutrient diseases can be cured with these single nutrients, right? So single nutrient deficiencies can be cured. We know what the nutrients are. That's fantastic. The major discoveries is that now we know that foods deliver complexity, and there's a lot of complexity we need to understand, but we know that the complexity of foods is really where we need to focus on moving forward if we want to address the whole body, if we want to address health. And so that now we know that. So that's a huge development, because that came with the advancement of very intense technology, like these methodologies that were able to help us shed light on these outcomes.
So Jennifer, from your perspective then, what are maybe some challenges or some barriers or issues, if you could think of one or two that you think we need to address or overcome to move this forward, what would those be?
So I think the major challenges is getting everyone else on board. Addressing health with food patterns is not going to be easy, because food is complex and the body is complex. It's so much easier to use that reductionist approach, where you have a single nutrient and you can isolate it and then measure it in people. So the implementation and the study of it and getting people on board to work together in a collaborative and multidisciplinary fashion is critical. And so I could see that being some growing pains to move forward with that, but it should be the priority. That's where we should be going.
It's a great point. And I definitely think that for those of us closer to the field of nutrition and nutrition education, looking at the USDA dietary guidelines for Americans, we've even seen this be a factor of that discussion in the last decade, especially talking exactly about what you just brought up, moving from isolated nutrients to the food pattern, and then making that shift is going to take a multi-collaborative sectoral transition. So great point. So with your experience looking at collaborative action, since we brought that up, what would be priorities that you think we could take to support specifically the topic discussed today, the needs for growth, development, and lifelong success for the child? So
the first thing is the urgent, immediate priority, and that is that pregnant women and their partners should have access to prenatal education and support. And within that prenatal education should include diet for mom, but diet for her infant and her child. And that should also include lactation support. The second thing is that children should have access to breakfast and lunch in schools. Every child should be fed breakfast and lunch. I think if we can feed all kids and feed all infants healthy, with breast milk. So breast milk for infants and a healthy breakfast and lunch for children, that we could at least sort of put a Band-Aid on things. And as we are working on the long-term goal, which would then be to build consortiums of interdisciplinary teams that include clinicians, immunologists, microbiologists, policy makers, government, economists, environmentalists. I mean, we need a whole team of individuals who can bring their experts to the table, so that we can actually reshape the way we think about food. We're going to move mountains, and we need a lot of people who have these expertise to help us with that effort.
That's a really great point. And I know, just kind of bringing up one of the areas you used in this discussion, really bringing up, we're very familiar with the issues that children are facing in terms of chronic disease, childhood obesity, and then those related comorbidities. We talked about stunting and these other issues that are also happening simultaneously. And so you talked a little bit about how we need to look at this dynamic between the immune system, the gut microbiome, neurological brain development, and growth and metabolism. So kind of those three areas, really seeing things differently than maybe we have looked at them in the past to address these issues and support optimal health for children. And you shared a lot about lactation being a model that we can look to that gives us information on how to do this. For infants, it's the gold standard, but then looking at applying that to children's eating patterns as they grow. So beyond breast milk, when they're eating their pattern, as you suggested, we hear questions a lot like, for example, milk, you mentioned dairy milk as an example, is only meant for baby cows. But in this example, you're really talking about how, no, these are examples of foods that serve as a model and a pattern for developing health more broadly. And so can you speak to someone that says those kinds of things so we can really understand those
absolutely.
changes?
Absolutely. So definitely breast milk is made for an infant, right? But breast milk, or lactation essentially, can teach us so much about how to feed someone like an infant, someone who has a developmental need, or a metabolic need, or a neurological need, or an immunological need, or a microbiome need. So we really can learn a lot from breast milk and lactation and apply it to other populations. So for example, milk, breast milk, cow milk, goat milk, they all have a matrix. They all deliver complete proteins. They all deliver calcium and phosphorus in these formed casein micelles, for example. They all have lactoferrin on some level to deliver iron and that sort of thing. So let's think innovatively. How can we dissect milk and learn what's in it? What does it do? We know what the infant needs, but there are people, for example, who need, let's say, a vaccine, and we want their immune system to respond to it. Maybe we can give them some milk protein to help stimulate the immune system. Or, think ingeniously in that sort of, think, well, how else can we deliver fermented foods? Well, obviously we can culture milk and deliver, let's say, a kefir that has a chock full of microorganisms, but also protein, an efficient form of protein, and calcium. So now mothers can receive 30% of their calcium from kefir and the microorganisms and the protein that she needs, rather than, say, consume, almond milk with calcium. Almond milk doesn't have the protein. Almond milk doesn't have the fermented cultures. Almond milk doesn't, so there are things that are lacking in some other foods that I think milk really delivers so many components through its matrix. So that's why I learned from lactation. We can study it and then we can think, okay, let's see how we can apply it to other populations. So I'm not suggesting breast milk is for adults, breast milk is for babies, but breast milk can teach us about how to feed adults.
I think you bring up such great points using that example, because when you look at the pattern, that we talked, you presented a great example there on milk. And the same thing could be applied to those foods that you mentioned we need more of in the pattern. So fruits and vegetables, looking at, instead of obviously providing juice, the optimal would be the whole fruit. You're getting the matrix. You're getting the same thing with grains. You want the whole grain because you're getting the matrix, and all that enhances the quality of the child's diet and also supports these other additional functions beyond just the nutritional needs. So it's a great model to discuss and for us to all think about. So thank you.
Oh, you're welcome.
And then lastly, just in kind of wrapping up this very stimulating conversation, it's been really enlightening and eye-opening and a lot for us to think through. Do you have any final thoughts or key recommendations for moving forward that you would, recommend, especially related to this initiative or this specific topic?
Well, I think, it's more like highlighting the overall big picture. I think we need to think about food as not just delivering the components, which is what we've been doing for the last 100 years. We have to think of food as a matrix, a composite. And if it's part of our language, our vernacular, if we actually talk about food matrix, food synergy, if it becomes a regular part of our education system, I think that people will get it. And I think it's really important that education is implemented in healthcare, right? So pregnant women need to understand food, because if they understand that it's not just, nutrients and they can just take a supplement, but they actually are getting more than that, I think they would do it, because when women are pregnant and they have children, they would do anything for their child. And so if they had that knowledge, if we only gave them some information, I think they would do it. I think they would make better choices, and especially if we could make it more available, and we focused on matrix rather than these nutrients themselves.
Well, that's a great thing to leave it with. So, wrapping up the education piece, food access, so increasing the access and the availability, all of those things, I think, speak to the need for collaborative action and coming together on this. So with that, thank you so much, Jennifer. I'm going to let Christopher share any final thoughts related to his perspective as we finalize this thought-provoking webinar.
That's a good reminder. Okay, thank you, Dr. Smilowicz. I really appreciate your presentation. You made a very compelling case for the first 1,000 days. You could have been a lawyer with that kind of compelling case. What I loved was your focus on evidence-based research and practices. As you know, that's just a critical component, and speaks to the important role that the academic educational institutions play in any collaborative effort. It's easy to get a bunch of nonprofits together, public agencies, around a shared goal, but we really need the evidence-based research and practices to support it and provide the compelling case for the work. I don't know to what extent you're doing applied research or possibly in collaborative efforts with nonprofits that are more field-based, but certainly the opportunity of this initiative would be to bring together diverse stakeholders representing public agencies, nonprofits, academic, who would be able to find those complementarity strengths, skills, resources to pursue in a more collaborative fashion the work that needs to be carried out. So thank you for raising that issue about collaboration. Clearly that's critical, and it's cross-disciplinary, it's cross-sector, etc. So thank you very much, appreciate it.
Oh, it's my pleasure. Thank you so much, Christopher.
And I want to thank thank you both, Dr. Smilowicz and I'm Christopher with Glenn Price Group, for today's webinar, and looking forward to continuing this important work for the well-nourished, brighter futures.